And what we're going to be talking about with this is if you have shortness of breath that is caused specifically by fluid that is going from the capillaries in the lungs into the interstitium and into the alveoli. So at that point, so you have, if you look at the lungs, you have the capillaries in the lungs where blood is going to flow. And then you have the alveoli with oxygen. And oxygen is supposed to go across the interstitial space into the capillaries and move on blood cells. That's the idea. When you have acute pulmonary edema or acute congestive heart failure, what's happening here is that you're going to have fluid that is going to be going into the interstitial space and into the alveoli. And it's going to essentially cause a barrier to make it more difficult for you to get the oxygen across this space and back to the capillaries. So the first question, I guess, is sort of why does this happen?
Yes, they're for you guys.
There's a very complicated equation. This is why it happened. And this is called the Starling equation, or Starling. But essentially it tells you sort of what's happened within the interspace between any capillary and any set of cells. So this also actually works when we're talking about edema in the legs. It will work with the kidneys. So this is the movement of fluid across spaces depending on fluid. And essentially it's going to be the pressures within the capillaries minus the pressures within the fluid space. If this pressure gradient is going this way, the fluid is going to go in that direction. The pressure is going this way, it goes that way. It's simple. And then the other part is the onconic pressure. So inside your bloodstream, you've got a lot of stuff. You've got red blood cells. But really, a lot of this is going to be is protein. So the protein albumin is the majority of this. It causes 80% of the sort of the stuff in the bloodstream. And then you also have electrolytes. How many, before I go forward, how many of you guys have taken chemistry already, or are taking it now? And how many of you have exams tomorrow in chemistry? And how many of you taking biology? I'm assuming a bunch of you taking biology. Let's go. Physics? Good. Organic chemistry?
Oh, yeah.
Yeah. Okay. So, when you start doing, in some biology classes, and probably in your physiology classes, they're going to talk to you about how the fluid shifts based on electronic pressure. They should have also talked to you about this in chemistry. Do they do that with membranes? Or that they put two fluids, fluid 1, fluid 2. They put a permeable membrane in between them. And then you fill one fluid up with a whole bunch of stuff that has like albumin or something. You'll get transfer of the fluid from this set over, from this side over here across this permeable membrane over here, so that it will hopefully balance out the onconic pressure from all of these little things that are all. Does that make sense? The same thing is happening within the cells over here as well. And the reason why that becomes important is when you're talking about heart failure, and that's mostly an issue of hydraulic pressure changes. I'm going to go right into that in a second. But when you're talking about non-heart failure causes of pulmonary edema, most of those things are caused by osmotic or onconic pressure changes. And then there's this coefficient rho that they have here, which is specifically talking about this membrane here. Does that membrane become more or less leaky? Because if this membrane changes, then that changes all of the rest of the equation. Okay? Forget this. This is the background, and I went through this mostly so that you can get a sense that there's something else bigger behind all of this, because I'm now going to try to make it much a little more simple. heart failure comes in essentially two different forms. When we talk about chronic heart failure, you can have systolic heart failure, you can have diastolic. Systolic heart failure is when the pump itself doesn't pump very much, right? It can't push blood out. Diastolic heart failure, on the other hand, it pumps normally, but it can't relax easily. Both of these things essentially are causing blood to back up into the lungs. So here's your heart. We're just going to this right atrium. Blood comes in from the body. Goes across the tricuspid valve into the right ventricle. The ventricle pushes it out into the pulmonary artery and the lungs. Comes back from the lungs into the left atrium, across the mitral valve, into the left ventricle, which is the main pumping chamber, and out the aorta to the bottom. Everyone this recognize this?
Cheers.
Now it's split up. The atrium, the ventricle, lungs. Lungs into the left atrium, left ventricle. Anything that's going to cause backup of fluid from the left ventricle into the left atrium then will transmit that back into the lungs. And that's transmitted back into the lungs. The capillary pressure increases. As the capillary pressure increases, the fluid is going to shift across into the alveoli. And that's what's going to cause pulmonary edema. Then, that pressure is going to transmit back into the right ventricle, and in a more chronic state, from the right ventricle to the right atrium to the rest of the body. And that's when you have people who have heart failure, they have edema in their legs. Because the pressure is being backed up here to here to here to here. We're going to focus mostly now on the left. So there's a bunch of things that are going to cause left ventricular failure. And just to go over them very briefly, when you're talking about systolic failure, so the pump isn't pumping, what causes that? The main cause is that they have coronary artery disease. They have ischemia that's causing the pump to fail. They've had heart attacks and had bypass surgery. Hypertension, so long-standing high blood pressure causes that pump to fail, just as if you were pumping iron forever and ever and ever, and then at some point that muscle's going to break down and it's not going to be able to continue. Valvular heart disease, usually in the aorta or in the mitral valve, will cause it to fail because it's causing it to work too hard. Leaky valves cause the heart to pump twice as much as it needs to pump. Stenotic valves cause an increased pressure gradient of which it's going to try to pump out. Other things can cause it as well. Chemotherapy is causing toxins. Viral illnesses will cause it, like cold flu those are sort of common. Diastolic failure, on the other hand, when the heart can't relax quite as common, is more common in people as they get older. The heart just becomes stiffer over time with age. Acute ischemia can cause the heart to not relax quite as much as we want to. Hypertension, thickening of the heart from hypertrophy. So remember again to the muscle building concept. We're building muscle, the muscle gets thickened. So early on with high blood pressure, that muscle will get thickened. There's also some genetic abnormalities in the concept. And as that muscle gets thickened, it's also harder to relax. Has anybody ever worked out and the next day the muscles are really stiff but can't? It's harder to so that's what's here. So that's essentially the same thing that's causing causing heart failure. Yeah, you're not all that simple. Okay. In addition, other things can cause the heart not to relax quite as easily. And the big one is going to be tachycardia. So if the heart's going really, really fast, imagine the heart pumping really, really fast. the time for the blood to get in and get out of the heart is really increased. Diastole is really probably the most important part of the heart cycle. We think of everything being pumped out, but that's not really the important. The important part is when it's relaxing. As the heart relaxes, it's pulling blood into the heart. Relaxation is actually the energy requiring stage of the cardiac cycle. It's sort of like a spring. It takes a lot to pull that spring open, and then the spring closes and the muscles contract. And when you're looking at the troponins and the active myosin in muscles, it is the relaxation part that is the energy requiring stage. And when the proteins coming together is when the heart system is actually the sort of anyways, as the heart's becoming faster and faster, you don't have that time to allow the heart to relax. As the heart can't relax, blood starts getting backed up. As blood starts getting backed up, you start getting a little short of breath. Then what happens? You're short of breath, you're now working a little bit harder. As you work harder, what happens to your blood pressure? Your blood pressure goes up. As your blood pressure goes up, and your aorta, then the blood pressure goes up in the ventricle. As the blood pressure goes up in the ventricle, then it has to work harder to pump the blood out. What happens when the heart's working harder? It's harder to relax it. As it's harder to relax, the oxygen, the requirement of oxygen into the wall gets higher, the wall stress gets higher. As the wall stress gets higher, then the heart can't relax more, and what happens with that? That cycle, the end-diastolic pressure goes up, the pressure in the atrium goes up again, and the pressure in the lungs goes up. The transcapillary pressure goes up, more fluid to the lungs, more heart failure. So it's this bad cycle. And your job is to break the cycle. So we've got someone who comes in with acute pulmonary disease. What do you think about this? Because you're a new EMT, you're a patient, there's a patient like this. You're thinking, you got it. Shoot the compensatory heart. The first thing you need to do is you have to think at least a little bit about differential diagnosis. Not everything that causes shortness of breath is heart failure. Although I know that the emergency room doctors call me all the time because it's not heart failure. It really isn't. So things that look like heart failure. Pneumonia looks like heart failure. Pneumonia causes people to be short of breath, causes them to have crackles in their lungs, causes them to work harder. It can be heart failure, it can be pneumonia. I get this all the time. Pneumonia usually has other things associated with it, like fevers.